It is essential in research designing that you know your variables. So may I present to you the four types of variable. The first one is the independent variable. The second one is the dependent variable. The third one is extraneous, and lastly, the confounding variable or the linking variable. By definition, independent variable is the variable being manipulated. Say for example, in the case of a study where you test the efficacy of a fertilizer to the height increment of a plant, the independent variable is the type or the amount of fertilizer used, while the dependent variable on that study is the height increment of the plant. So, meaning to say, dependent variable is the variable dependent on the independent variable, or it is the variable being tested in the experiment. Now, the third one is the extraneous variable. These are variables which you cannot control, but or you can control this one, but if left uncontrolled, it will become a confounding variable. Now, these variables are not necessarily being studied, but it is present in the setup. Now, it can affect the validity of result. And so, as much as possible, we try to control everything in our experiment. The last variable is the confounding variable. These variables influences both independent and dependent variable. Now, let's visualize the types of variable in an example. So suppose a researcher wanted to conduct a study on the weight increment of tilapia. Our experimental unit is tilapia, our EU is tilapia, cultured in a fish pens using varying amounts of fish pellet and leftover breads as supplemental feeds. Now, let's identify the variables. What is the independent variable in that study? It is the amount and the type of supplemental feed, which is fish pellet and leftover breads. Now, what is the dependent variable? It is the weight increment of tilapia. Third one is the extraneous variable or outside variable. It's the size of pen, duration of the study, and the source of tilapia. Now, the confounding or the linking variable, and these are the variables which can readily affect independent and dependent variable, the pH, temperature, age of tilapia, and its sex. Now, let me introduce you to research groups. The first research group is the control group, and the second one is the experimental group. Now, we both use this one for comparison and to test significant differences. So, what is the control group in this study? It's the tilapia treated with fish pellet. And what is the experimental group? It's the tilapia fed or treated with leftover breads. So let's put the identified variables in this causal diagram of experimentation. We use the causal diagram of experimentation to visualize the relationships of the variables. So we put the independent variable here. Now we use this arrow as marker that this one affects this one, and this one will be the result. Now extraneous variable is here, and we put some arrow here to denote that the extraneous variable may affect the validity of the experiment. And the confounding variable is found here at the top with a connecting line. suggesting that it affects both independent variable and dependent variable. So I hope that's clear. Now, when it comes to variables in engineering projects, um, we use variables in the engineering studies in usually during the trial phase or the testing phase. Let's have an example. Say you develop a friction pen, I, a pen which readily converts friction F to electricity. So you have developed a product, a pen which converts friction to electricity. Now, how will you determine the variables of your experiment? So it is said that you can identify the variables during or only during trial phase or testing phase. So what's the IV and what's the dependent variable? So the IV or the independent variable may be the amount of friction and what is the dependent variable? The amount of electricity produced. So I hope that this will help those students undergoing engineering projects or developing products.